Okay, guys, so now we know what a binomial setting is. Now we want to figure out the probability of something happening when it's part of a binomial setting. Okay, so probabilities of a binomial distribution is another way to think about it. Binomial setting, binomial distribution, kind of similar. All right, now, example 18, when rolling two dice, the probability of rolling doubles is 1/6. Suppose a game player rolls the dice 4 times, hoping to roll doubles. Find the probability that the player gets doubles twice in 4 attempts. Let's just talk about that binomial setting or that binomial distribution that we have, right? Okay, so is it a binomial setting? BINS, B-I-N-S, what we just talked about in the previous video. B is binary, success, failure. What is our success in this? Our success is that we're going to get doubles. Okay. I, independence. Do we have independence here? Okay. No, or yes, we do. Sorry. We do have independence. When we roll dice, what we get when we roll dice one time does not affect what we get the next time. Rolling doubles or rolling dice is independent of each other. N, the number of trials is fixed. How many times are we rolling this dice? 4 times. S, probability of success. What is the probability of success? Rolling doubles. And each time we roll 2 dice, the probability of success is 1/6. Okay, now let's get to the question. Find the probability that a player gets doubles twice in 4 attempts. Now, when I talk about a binomial distribution, I'm talking about everything that could happen. So we would figure out the probability of getting 0 doubles in 4 attempts, 1 double in 4 attempts, 2 doubles in 4 attempts, 3 doubles in 4 attempts, and 4 doubles in 4 attempts. That's a binomial distribution. All I care about right now, though, is figuring out the probability of getting doubles twice in 4 events. This is what I'm looking for. This is my x, my little x, I should say. My big X, here is my probability statement. My big X is what is the story, guys? What is the story? The story is that I am rolling doubles. I want to roll doubles. I'm going to roll 4 times. How many times do I want doubles? I want doubles twice. So that's my little x now. So it's basically saying here, out of 4 rolls, what's the probability that 2 of those rolls will be doubles? So we're going to plug this into a formula right now. Okay, we're going to plug this into a formula. I'm going to do this here. And again, I'm using my trusty mouse. So, bear with me here, but we can do it. Okay, so we're going to say the probability, the probability that x equals 2 is equal to, now, this thing right here is a combination. I'm going to talk about this in a second, okay? Little n here, that's our fixed number of trials. That's 4 right there. Out of 4 rolls, I want to know little x here, lowercase x. I want to know that I'm going to roll doubles twice in those 4 attempts. Now, what this symbol is in mathematics is that's a combination. So that means I could roll doubles on the first and the second out of the 4. I could roll the doubles on the first and the third out of the 4, the first and the fourth out of the 4, the second and the third, so on and so forth, right? Out of the 4, excuse me, I bit thumb up. This is taking into account all the different combinations, all the different ways that I can get doubles twice out of the 4 times that I roll it. Now next is P. P is right here. This is the probability of success. Probability of success. Okay. Let's plug that in now. So we take 4, choose 2, we say mathematically, times, sorry guys, I had to hide an iPad. Someone's dings are going off and it was driving me crazy. Sorry if it was driving you crazy. Forgive me if I repeat myself. Okay, so we have this 4, choose 2. That's taking into account all the different combinations of getting 2 doubles out of 4 attempts. Okay, I'm sorry, getting doubles twice out of 4 attempts. Now we have this P. This is the probability of success. So the probability of success we know is 1/6. To the x power, that x is how many times are we going to get that success? So we're going to get that success, right? We have that right here twice. So to the second power times now 1 minus p. So 1 minus 1/6 to the n minus 6th power. So that's my number of trials, 4 minus 2. Now here's the deal. I can teach you how to type this in your calculator, but what's going to be more useful is something that the graphing calculator does, and that's called a Binompdf. And I'm going to show you how to calculate all of this using a Binompdf in your calculator. Now, why did I just show you this formula? Because on a multiple choice question on the AP test, they're going to maybe ask you part A, but they're not going to give you the answer. They're not going to give you a decimal answer. What they're going to do is they're going to give you 4 part or A, B, C, or D answers. And they're going to take this information, they're going to plug it into the formula, and only one of them will be right. What they're questioning is, do you understand what this formula means? That this is the number of trials. This is the number of times we want success. This is the probability of success, and so on and so forth. So that's why I showed it to you. Now, you have to show your work on a free response, but you can still use this Binompdf to show your work. So first, let's fill it out. Binompdf. NP, I have K. It should actually be X, guys. This is an old slide, so make that an X for me. Thank you. Okay, so Binompdf, our N is our number of fixed trials. We have 4 fixed trials. Our P is our probability of success. That's 1/6. Our X, that's the number of times we want that success. So we want it twice, 2. Ladies and gentlemen, this is sweet. This is almost showing your work on the college, for the College Board, on the test. All you have to do now, when they ask you a question like this, find the probability that a player gets doubles twice in 4 attempts. You have to show me this, the probability that X equals 2. You do not have to show me this stuff. You need to know how this works for a multiple choice test. But then what you need to do is you need to write out Binompdf 4, 1, 6, 2, and then you put N below it, P below it, X below it. That's showing work. Typically, they don't like calculator speak for the College Board, but this time they're okay with it as long as you put that NPX. Now you're probably thinking, Miss Opal, what are you talking about? What is this Binompdf? Well, guys, it comes from our calculator, so let's find it now. Get your calculator out now. Okay, guys, you should have your calculator out now. We're going to look for the binomial distribution. We're going to hit second right now. And then you see right above the bars, there's that blue, and it says DISTR, distribution. So hit that. I scroll up because it's easier. And you can see right here, we have a Binompdf. So scroll up to that. Move this up. Hit enter. Now, if you have the old calculator, you're not going to see this. So what you're going to have to do is you're going to hit the number 4. Then there's a comma button right here. Then you're going to put 1/6, the 1 divided by 6. Again, there's a comma button right here. And then you're going to hit 2. And you're going to close the parentheses. The rest of us trials is 4. Probability is 1/6. Our X value is 2. And then we're going to hit paste. So those of you with the old calculator, it should look like this. Then you're going to hit enter, and you can see that probability right there, guys. So 0.1157 is our probability. Okay, next, part B. Should the player be surprised if he gets doubles more than twice in 4 attempts? Let's rewind to part A. What am I going to require on a test? I want to see this probability statement right here. The probability that X equals 2. Find the probability that the player gets doubles twice in 4 attempts. Out of 4 attempts right here, he gets it twice. I want to see your calculator speak right here with the NPX. Then I want to see your answer, 0.1157. You'll get 100% that way on that problem. Part B is a little different. Let's look at it. Should the player be surprised if he gets doubles more than twice in 4 attempts? How is this different? Can you tell? What will our probability statement look like? Our probability statement will look like this. Hey, we're going to roll doubles 4 times. That's capital letter X, right? We want to know the probability that we get it more than twice, so greater than 2. If he gets doubles more than twice in 4 attempts, so that means 3 or 4. Well, what does that mean now? How are we going to type that in our calculator? First of all, what you need to know, guys, is any time that we have an inequality, okay? A greater than, a less than, a greater than or equal to, a less than or equal to. We're going to use a binomial CDF. What that means is cumulative, okay? Cumulative. You have a cumulative GPA. That's your 9th grade, your 10th grade, your 11th grade, okay? So it's combining everything. The issue with the calculator, though, that a binomial CDF will only equal when you have the probability that X is, I gotta use my pen here, less than or equal to little x. Okay, our little x here is 2. Why? Because that's what they gave us, more than twice. We want to know more than twice. So what we have to do is we have to manipulate this statement so we can use the calculator. I mean, we could go ahead and we could use the calculator this way, because the probability that x is greater than 2 is the probability that x is equal to 3, or the probability that x is equal to 4. That's not too bad. We could use a PDF. A PDF is always, always, always when we have an x is equal to something, not an inequality. A CDF is when we have an inequality, but it only works for a less than or equal to. Now, we have this greater than. We could do a PDF for this one and a PDF for that one and add them together. But the issue is, guys, sometimes you may have your fixed number of trials being equal to 20. Well, then we would have to do 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 20. So what we're going to do, guys, is we are going to rewrite this statement. We are going to rewrite it as the probability of x is greater than 2. Under it to help me as guidance, I know what could happen. Hey, I'm rolling this dice 4 times. I could get doubles 0 times, 1 time, 2 times, 3 times, or 4 times. I want 3 or 4 times. But my calculator will only work for the probability that x is less than or equal to a number. So I'm going to use the complement rule. I'm going to say the probability that x is greater than or equal to 2 is 1 minus what we don't want. We want 3 and 4. We don't want 0, 1, or 2. That's the probability that x is less than or equal to 2. Okay? Now, because I have it set up as the probability that x is less than or equal to 2, I can use, oh, sorry, I went too far. I can use this binomial CDF. Okay, what is that going to look like next? I'm going to say 1 minus, well, what's a binomial CDF? It's just like what we had before, guys. Binomial CDF is an n, comma, p, comma, x. So I'm going to take binomial CDF, 1 minus a binomial CDF. N is 4 because we're rolling it 4 times. P is 1/6. X is 2. How do I know it's 2? Because I don't want 2, 1, or 0. That's the probability that x is less than or equal to 2. What I don't want. I'm using the complement rule. That then is equal to n, p, x. I go to my calculator. I take 1 minus second vars Binomial CDF, N is 4, P is the probability of success, 1/6, 2. Hit paste, hit enter, and there we go. There is my probability. Oops. So I get 0.0162. Now, the question is saying, should we be surprised by that if we get doubles more than twice in 4 attempts? Do you guys remember what the cutoff is? Right now, our cutoff is if anything happens and the probability of that happening is less than 5%, but it does happen, we should be surprised. So how should we state that? Yes, we would be surprised. Oops. Because the probability is very low. That's all you have to put right now. When it's less than 5%, just put the probability is very low. So we would be surprised if it would happen. What do I want to see for work, guys, on your test? I want to see the probability that X is greater than 2. I want to see this work. And then obviously we need to answer the question. Okay, I'm going to practice this with you on one more slide, but if you feel really confident, you can go ahead and start your work. I want to caution you though, this is my first time ever teaching this virtually, so I'm a little nervous. This sometimes can be tricky for people, this whole idea of rewriting the CDF. So I have one more slide where we're going to go through some things, okay? But let's just, again, if you feel confident, you can try it out on your own. So let's move on to the next slide, though I'd encourage you, if you feel at all uneasy, maybe take a quick little break, and then I'll try to take about 5 more minutes to practice some more problems. Here is the intervention, guys, if you were feeling like, oh, I didn't understand what she just in the last problem. This will get you hopefully feeling a little more settled. So what if we get a less than or greater than, an equal to is easy. That's a binomial PDF. You just use that every time. That's that part A. But what if we get a greater than, a less than, a greater than or equal to, a less than or equal to? What do I do? This example will hopefully solidify it for you, okay? So remember, a binomial CDF only works for the probability that X, capital letter X, that's your scenario, is less than or equal to little x. That's how many times you want your success, right? So we have this, you know, if someone's going to have babies, the probability of being a boy, the probability of a boy being born is 0.517. And the probability of a girl being born is 0.483. Consider a family planning on 5 children. Sorry, I talk too fast sometimes and then I stumble over my words. What is the chance that they will have at most 4 boys? So we need to think about this. What does at most mean? At most means we're going to have the probability. What's our scenario? Hey, people are planning on having 5 kids. Right? That's the scenario. We want at most 4 boys. What does at most mean? Less than or equal to 4. If you're struggling with figuring how it would go, just write it all out. We could have 0 boys, 1, 2, 3, 4, or 5 boys. At most means I'm having 4 or less than that, okay? I'm not going to have 5. If we get it like this, we're good. That's why we want to write out the probability statement, you guys, because that's going to help us then, okay? Well, we know then that, hey, our binomial CDF only works for less than or equal to lowercase x. So we just write out that binomial CDF N P X. Okay? Our N, what is our N? That's our fixed number of trials. They're going to have 5 children. Our P, what is the probability of having a boy? 0.517. How many times do we want this? 4. So I'm going to type that out. It goes a little faster. That's binomial CDF 5, 0.517, 4. Let's go to our calculator right now and figure that out. Second vars, binomial CDF, because it's an inequality, we have 5 trials. 0.517 is the probability of success. 4, paste. Again, I talked about if you have an older calculator, what to do. Hit enter. And let me shorten this up here. Our probability then on this one is 0.9631. In order to get credit on the test, you have to show me N, P, and X, as well as show me the statement and the final answer with 4 decimal places. Okay, let's go on to the next one. B, the probability, if we're going to have 5 children, what is the chance that we'll get less than 3 girls? Write it out if you need help. Hey, we could have 0 girls, 1 girl, 2 girls, 3 girls, 4 girls, or 5 girls. What do I want? I want less than 3. That's 0, 1, or 2. So how am I going to write this probability statement? I'm not going to write it as the probability that X is less than 3. I mean, I could, but I feel like that could really cause some problems for some of you. Why? Because the CDF only works for a less than or equal to. So what do I want? I want the probability. If I'm going to have 5 kids, that capital letter X, I'm going to have less than or equal to 2 girls. That's the same as less than 3 girls. That's why I think it's really helpful to write this out right here. Okay. So I get binom, CDF, 5 kids. The probability of having a girl is 0.483. And then what do I want here in my probability statement? That little x is 2 here. Again, that's why I really, really encourage you, write it out. Write it out. Figure out what I want. Okay? So I'm going to go to my calculator again. Second, vars. I'm going to scroll up. Binom CDF because it's an inequality. I'm having 5 trials. This time, though, I'm having girls. 0.483. I want 2 or less than that. I'm going to paste. Oops, sorry, guys. Okay, so that is then equal to 0.5319. Oops. I'm going to write my NPX under it, or you will lose credit. And this is what I want to see on a test right here. Let's do one more. We want, if we're going to have 5 kids, the probability of at least 2 boys. Again, please, I encourage you to write out all the possible situations. I could have 0 out of 5 boys, 1 out of 5 boys, 0 boys out of 5 kids, 1 boy out of 5 kids, 2 boys out of 5 kids, 3 boys out of 5 kids, so on and so forth. What does at least 2 boys mean? At least 2 boys means 2 or more than that. We just talked about in the previous example, which is more difficult than A and B, which I feel bad if you were confused. I should have started here. You guys, I feel bad. A virtual world, please give me grace. I'm sorry. Okay. This now we have to manipulate, right? Because now we want the probability that X is greater than or equal to 2, we now need to use the complement rule. We need to do 1 minus what we don't want. 1 minus what we don't want. We want 2 or more boys. We don't want 0 or 1. So that would be then 1 minus the probability that X is less than or equal to 1, which would give us then 1 minus binom CDF 5. It's boys now, so 0.517. And then comma 1, because that's what we have right here. NPX. We go to that calculator. 1 minus second vars. Scroll up. Hit enter. 5.517 1, paste, 0.83303. 330 then, okay? All right, I think you have it, but let's just finish strong and let's do one more. The probability of more than 2 boys. The probability of more than 2 boys, well, that's X is greater than 2. Again, we want everything written in some kind of form of less than or equal to. So like I said, write it out again. 0, 1. These are all the different ways we could get boys, right? If we're going to have 5 kids, we could have 0 boys out of 5, 1 out of 5, 2 out of 5, 3, 4, 5 out of 5 boys. I want to know the probability of getting more than 2 boys. That's 3, 4, or 5. This is the probability that X is greater than or equal to 3. So I need to rewrite this, you guys, because it's a greater than. Anytime we have a greater than, we do the complement rule. We need to do 1 minus what we don't want. So that is 1 minus the probability that X is less than or equal to 2, which is 1 minus binom CDF, I'm using my mouse, sorry guys, N5, probability 0.517, and then we have 2. NPX. We type that in our calculator. Let's finish strong, you guys. We can do it. I know I'm tired too. Second vars, binom, CDF, 5.5172. Paste, enter, 0.5319. Yowzers, guys, we made it. Can you believe it? I can't. 27 minutes. I so appreciate you. I want you to know I am here for you if you need something. I'm sorry I did not start with this slide. I should have. Okay, I should have. Hopefully, for those of you who understood it right away and you got the other side, you're good, but forgive me, guys. So have a great day, and then make sure you come see me in office hours or set up an appointment to maybe meet after school if you have any other questions. Talk to you later.